Guys, what I did was I pulled out about 20, I think I've got exactly 20 random identities that we should be able to solve with the material that we've covered so far in class. So what I'm going to do is I'm going to go through all 20 of those, and I haven't worked them out yet, so you're going to get to see exactly what I'm thinking, and I'll talk about um, maybe different approaches to solving these types of problems. Sometimes I'll work through it, and it's not going to work out perfect. Okay, it might be messy and I might have to restart over. But that's how identities work. Okay, so you're going to get to see exactly how I would work through them myself without actually going through and pre-working them. So here's our first, I'll put a number 1 here because this is the first guy that we're going to get to talk about. What I would probably do is first I would look to see anytime I've got like a double angle or a half angle floating around an identity, I'm leery of starting on the other side. So I'm thinking I'm probably going to want to start on this side just because I'm going to want to isolate that cosine, get that double angle out. Because it's hard to get it in to a double angle. So I'm going to start out here with this side. So one of my formulas that I can use for my double angle is cosine squared. So I can say this. I can say cosine of 2 times an angle is equal to the cosine squared of that angle minus the sine squared of that angle. Now, while I'm working these, I'm constantly looking over here to see what do I need it to look like. Well, I've got it split, so that's nice. So if you look here, I got that thing split. So now what I could do is I need these guys to be like this guy here to be like a cotangent, and this guy over here to be a tangent. So one thing I could do is I could try. Well, let's try a couple things here. The first thing I could try is just dividing everything by cosine squared. If I do that, if I divide everything by cosine squared, I would get this. So cosine squared theta minus sine squared theta over cosine squared theta cosine squared theta, like that. So this would give me 1 minus tangent squared theta. So we could take that guy and, well, we're really kind of stuck here. So let's backtrack a little bit. Looks like that might be a dead end. Maybe we can go further. Let's see what else we can do with this. Maybe we want to try to split this guy up. So we know that, you know what? I'm not seeing how to do it on this side. Okay. So let's try this side over here. If I was going to attempt this, I would probably switch everything to sine and cosine. So this I would do is cosine theta over sine theta minus sine theta over cosine theta. And that whole thing is going to be divided by cosine theta over sine theta plus sine theta over cosine theta, like that. Now the numerator, I'll get a common denominator. So cosine squared theta minus sine squared theta over sine theta times cosine theta. And I would divide that by cosine squared theta plus sine squared theta over sine theta times cosine theta. So this, I hate to even write this out because it's a lot of work, but essentially I'm going to take this numerator and divide it by this denominator, which is going to take the numerator and multiply by the reciprocal of the denominator. So it's going to look like this: cosine squared minus sine squared over sine times cosine. And then I'm going to have sine cosine on the top here, and then this guy's going to be on the bottom. So it's going to be cosine squared plus sine squared, like that. This is a good sign here, no pun intended, because this guy and this guy cancel. And so I'm going to be left with just cosine squared theta minus sine squared theta over cosine squared theta plus sine squared theta. Okay, now we need to get back to cosine 2 theta. Well, there's three. I'm going to write them down. So there's three formulas for the double angle of cosine. One is cosine squared theta minus sine squared theta, right? And that's the one we're going to use here. And then we've got two other ones. So I'm going to write them down because I said I would here, but we're not going to use either of these two. The one I'm going to use is this guy up here, because cosine squared plus sine squared is equal to 1. So this is going to give me cosine squared theta minus sine squared theta over 1, and cosine squared minus sine squared is the cosine of 2 theta. Okay, and there's our proof. Now if you want to start on the right side, you could just work backward like this. Okay, but you can see that that line of logic isn't quite as easy as coming back this way.